let's try the next geometry problem here. It says here, calculate with reasons the size of QTS. Now, you should read all of this stuff about the cyclic quadrilateral, where the angles are, the idea that SR is, that QT is perpendicular. QT is perpendicular to SR. That's what this 90 degrees is about. They want this to figure out what the angle of QTS is right here, this angle right here. And we're given this angle up here of 35 degrees. So how could we do that? Well, you see this triangle here? This triangle here is a triangle where we can get at this angle right here, which is R. So because of the exterior angle theorem, R must be 55 degrees. R must be 55 degrees. But if R is 55 degrees, then QTS must be 55 degrees because they open up to the same segment as Q. So this angle here should be 55 degrees. Okay. And also R is equal to S1. So I should have put 55 degrees right there because it opens up to the same segment right there. Prove that PQ is parallel to SR. PQ is parallel to SR. Well, we can get the QPS, QPS. Those are the opposite angles in a cyclic chord. They're 125. Well, we know that S1 is 55 degrees because S1 equals R. And now we know 125 and 55 are 180 degrees. So they're co-interior angles. So PQ has to be parallel to SR because the co-interior angles sum to 180. S1 and the one we just figured out that was 125. Prove that PT is the diameter of this circle. Well, if we could prove that this is 90 degrees, then by angles on a semicircle, PT would have to be the diameter. Well, S2 must be 35 because if angles in CQ2 and S2 open up to the same segment of the circle, RT here, the same chord. So PT must be the diameter because look at that, 25 and 50, 35 and 55. PST is 90 degrees. So it's the converse of angles on a semicircle that force PT to be the diameter. Well, there's those three questions all done.